German chemist Fritz Hoffman made a groundbreaking discovery when he opened sealed metal containers filled with methyl isoprene that had been heated to various temperatures. The liquid had transformed into an elastic substance resembling natural rubber, proving that rubber could be synthesized in a laboratory, working for the dye manufacturer Friedrich Bayer and Co. In Elberfeld, Hoffman's discovery came at a crucial time when Germany imported nearly all its rubber from British and Dutch colonies in Southeast Asia. The implications were significant for German military planning. Any future conflict would immediately sever access to rubber supplies. Hoffman's primitive synthetic rubber would eventually evolve into Buna, a material that became critical to Nazi Germany's war machine. By the final year of World War II, nearly all rubber used by the Wehrmacht came from synthetic sources. Without Buna, Germany's mechanized warfare would have ceased operations years earlier. Pre-war dependency and World War I. Crisis Germany depended entirely on imported natural rubber from British Malaya and the Dutch East Indies, which controlled the vast majority of global natural rubber production through extensive plantations. Rubber had become essential for modern industry, including tires, gaskets, electrical insulation, and various hoses. As automobiles and mechanization spread, rubber consumption increased dramatically. Germany imported approximately 40,000 tons of natural rubber annually before the First World War. When Britain blockaded German ports at the outbreak of World War I, rubber imports stopped immediately. Germany's stockpiles were depleted within months, crippling military vehicles, aircraft, and industrial production. German chemists attempted to create substitutes, producing a primitive synthetic rubber from dimethylbutadiene. However, this material proved inferior, less elastic, prone to hardening in cold weather, and requiring enormous energy to produce. Germany manufactured approximately 2,500 tons of this methyl rubber during the war, barely a fraction of what was needed. After Germany's defeat, the rubber supply problem remained a critical concern for military planners. Any future conflict would again cut off rubber imports, making a domestic rubber source essential for national security. The IG Farben breakthrough. The decisive breakthrough came from IG Farben, the massive German chemical conglomerate formed through the merger of 6 companies, including Bayer, BASF, and Hoechst. By the late 1920s, IG Farben had become the largest chemical company in Europe and the 4th largest corporation worldwide. 2 chemists at IG Farben's Leverkusen laboratory, Walter Bach and Eduard Schunker, successfully synthesized a copolymer of butadiene and styrene. This new synthetic rubber, designated Buna S, represented a genuine breakthrough. The name derived from its chemical components, butadiene, sodium, the original catalyst, natrium in German, and styrene. Buna S possessed properties far superior to World War I-era synthetic rubber. It was elastic, durable, and resistant to abrasion. When IG Farben displayed tires made from Buna S at the Berlin Motor Show, they created a sensation, lasting significantly longer than natural rubber tires under road conditions. The same year, chemists developed Buna N, also called perbunin, a copolymer of butadiene and acrylonitrile. Buna N's key property was resistance to oil and petroleum products, making it essential for gaskets, fuel hoses, and engine seals. By the mid-1930s, IG Farben had developed synthetic rubber that could genuinely replace natural rubber in most applications. The challenge shifted from technical feasibility to production capacity, Nazi mobilization, and industrial expansion. When Adolf Hitler came to power, Nazi economic policy pursued autarky, total national self-sufficiency in strategic materials. Germany would never again face starvation by blockade as it had during World War I. Immediately after the Nazi takeover, the Wehrmacht and IG Farben resumed negotiations about Buna production. These talks resulted in state support for Buna production because of its military significance for motorized warfare. Hitler appointed Hermann Göring as Commissioner for Raw Materials to implement a 4-year plan preparing Germany's economy for war. Karl Krauk, a member of IG Farben's supervisory board, participated decisively in developing the plan. The 4-year plan set ambitious synthetic rubber production targets at 72,000 tons per year from 3 new plants. IG Farben's board initially resisted rapid expansion, wanting to achieve product quality that would make Buna competitive with natural rubber on the world market. The breakthrough came when the Nazi government agreed to guarantee operating costs, amortization, and interest payments. After securing arrangements similar to those made for synthetic fuel, IG Farben agreed to build large-scale production facilities. The foundation stone was laid for Buna Werke GmbH Schkopau near Halle in central Germany. Production of synthetic rubber commenced there, and the factory was generating profits within 2 years. A second factory, Hulswerk in Marl, also started Buna rubber production. The production process was complex, requiring 4 stages of chemical processing with polymerization of butadiene mixed with styrene in emulsion. The raw material acetylene needed for Buna production came from coal through the arcing process, which was then converted to butadiene. Wartime production and expansion. When World War II began, Germany's dependence on imported natural rubber ranged between 80 and 90%. British and French naval forces immediately blockaded German ports, and natural rubber imports ceased within months. However, unlike World War I, Germany now had functioning synthetic rubber plants. Buna production ramped up rapidly as war demands intensified. As the war progressed, Germany's synthetic rubber production increased dramatically, while natural rubber became almost unavailable. By the final year of the war, only a tiny fraction of rubber used in Germany was natural. The rest was Buna. The Wehrmacht's supply, transport, and combat vehicles relied entirely on Buna production for tires and track cushioning. Every tank, truck, aircraft, and piece of equipment required rubber components. After Wehrmacht victories in Poland and Western Europe, planned targets for Buna production increased further. IG Farben estimated that substantial annual production would be required to meet total rubber requirements in Nazi-controlled Europe. However, production capacities at the war's start fell far short of targets, requiring massive expansion. The Auschwitz atrocity. This created the context for IG Farben's most notorious decision, building a Buna plant at Auschwitz. Heinrich Himmler signed an order supporting construction of an IG Farben Buna N synthetic rubber plant near the Monowitz concentration camp, part of the Auschwitz complex in German-occupied Poland. The location choice involved consideration of industrial factors. Proximity to Upper Silesian coal mines made industrial sense for a coal-dependent process. However, the availability of massive forced labor at Auschwitz made it economically attractive under Nazi logic. Construction employed German workers alongside thousands of prisoners from Auschwitz. An estimated 35,000 to 50,000 people died on the forced labor details for Buna production in concentration camp conditions. Jewish prisoners, Soviet POWs, Polish political prisoners, and other inmates were worked to death building the plant. The Monowitz Buna facility, also called Auschwitz III, became one of the largest subcamps of Auschwitz. A private prison camp was built on factory grounds to house laborers. Prisoners worked 12-hour shifts with minimal food, beaten by SS guards and civilian overseers. Those too weak to work were sent to the gas chambers at Auschwitz to Birkenau. IG Farben paid the SS for each prisoner supplied, 3 to 4 Reichsmarks per day for unskilled labor, more for skilled workers. The company calculated that average prisoner lifespan before death from exhaustion, disease, or murder was 3 months. Despite massive investment and brutal exploitation, the Monowitz Buna plant never produced rubber during its wartime existence. Technical difficulties, Allied bombing, and the chaos of Germany's collapse meant the facility remained incomplete when Soviet forces liberated Auschwitz. Technology transferred to Allied nations. Even as Germany built its synthetic rubber industry with slave labor, the technology itself spread to other nations, including Germany's enemies. Before the war, IG Farben had partnerships with American companies, particularly Standard Oil Company of New Jersey, now Exxon, agreeing to share knowledge on petroleum products, including synthetic rubber. This gave American companies access to German Buna technology prior to World War II. When Japan attacked Pearl Harbor and seized British Malaya and the Dutch East Indies, the United States suddenly faced the same rubber crisis Germany had confronted in World War I. Japan controlled approximately 90% of world rubber production and immediately cut off exports to America. President Franklin Roosevelt created the Rubber Reserve Company to stockpile natural rubber and regulate synthetic rubber production using German Buna technology as a foundation. American companies developed their own synthetic rubber. Standard Oil reformulated Buna rubber into butyl rubber, which held air significantly better than natural rubber. The United States developed GRS, government rubber styrene, essentially identical to German Buna S, a copolymer of 75% butadiene and 25% styrene. Production exploded under massive government stimulus. The synthetic rubber industry grew from 4 plants to 51 plants, operated by various chemical, oil, and rubber companies. Production increased from thousands of tons to hundreds of thousands of tons annually. By war's end, America was producing more synthetic rubber than Germany, using the same basic technology German chemists had invented, but with free labor instead of slaves. Post-war reckoning and continuation. After Germany's defeat, Allied forces seized IG Farben facilities. The scale of the company's involvement in Nazi crimes became clear as investigators documented the Monowitz-Buna operation. 24 IG Farben executives were indicted for war crimes in the subsequent Nuremberg trials, charged with slavery, mass murder, and crimes against humanity related to forced labor at Auschwitz and other locations. A United States Justice Department lawyer investigating the company noted that without IG Farben's immense productive facilities, far-reaching research, varied technical expertise, and overall concentration of economic power, Germany would not have been in a position to start its aggressive war. By the middle of the war, IG Farben was manufacturing products worth billions of marks in hundreds of facilities across occupied Europe. Almost half its workforce consisted of slave labor or conscripts, including thousands of Auschwitz prisoners. Staff of the Bayer Group at IG Farben conducted medical experiments on concentration camp inmates at Auschwitz and Mauthausen, led by Bayer employee Helmuth Feder, an Auschwitz camp physician and SS captain. The Nuremberg verdict found 13 defendants guilty, with sentences ranging from 1 to 8 years imprisonment. Many considered the sentences too lenient given the scale of crimes. Several convicted executives returned to positions of influence in German chemical industry after their release. IG Farben was dissolved by Allied order, and its constituent companies were re-established as separate entities. Parts in East Germany were nationalized. Legacy and continuation. Despite its association with Nazi crimes, Buna technology itself proved valuable and enduring. Synthetic rubber production continued worldwide after the war. Under Soviet administration, Buna Schkopau was expropriated to cover Soviet reparation demands and later transferred into a publicly owned corporation that became one of the 5 largest industrial combines in East Germany. In West Germany, production of Buna was initially prohibited by British occupation authorities. It was not authorized again until the early 1950s as a result of the Korean War, when supplies of natural rubber were jeopardized by military conflict in the Far East. Companies established subsidiaries for synthetic rubber production, and a wider product range developed from the original Buna production for the tire industry. By the 1950s, use of synthetic rubber worldwide outpaced natural rubber. Today, more than 70% of rubber production utilizes synthetic rubber. Styrene-butadiene rubber, essentially Buna S, remains one of the most important materials in tire manufacturing. The Schkopau synthetic rubber production plant was purchased by a Polish chemical company and continues operating, now producing rubber for civilian markets, using the same basic chemical processes invented in the 1920s. Historical reflection. The history of Buna reveals an uncomfortable truth about technological innovation. Brilliant science can serve evil purposes. The chemists who invented Buna S were genuine innovators, solving a real scientific problem. Their copolymerization process represented legitimate chemical engineering achievement, and the earlier discovery had laid groundwork for an entire industry. However, when that innovation was harnessed to Nazi Germany's war machine, maintained through slave labor, and produced in a factory where inmates were worked to death, the achievement became inseparable from atrocity. IG Farben executives claimed after the war that they were merely businessmen manufacturing products. Otto Ambros, who selected the Auschwitz location for the Buna plant, testified that the company had no choice but to use forced labor since the SS controlled labor allocation in occupied territories. The Nuremberg court rejected these defenses. Choosing to build at Auschwitz, negotiating prices per prisoner with the SS, and working inmates to death while extracting profit were conscious decisions, not inevitable consequences of wartime conditions. German chemical journals after World War II largely avoided mentioning Auschwitz when discussing Buna history. Industrial publications from Bayer AG, Hulls AG, and later Lanxess AG, the current corporate descendant, initially did not include the word Auschwitz in their synthetic rubber histories. In recent decades, this has changed, with a clear step toward a fundamentally new culture of remembrance becoming evident. Bayer AG openly addressed its Nazi past through a history project, including establishing a memorial site for forced laborers at former IG Farben sites, and supporting an exhibition on IG Farben and Buna Monowitz. Germany's synthetic rubber program achieved its strategic goal. Buna production allowed Nazi Germany to wage mechanized war for 6 years, despite complete loss of natural rubber sources. Without Buna, Wehrmacht vehicles would have been immobilized, Luftwaffe aircraft grounded, and German industry paralyzed years earlier. The technology was a genuine achievement. German chemists solved a problem that had defeated scientists for decades. creating a material competitive with nature's product using only coal, water, and chemistry. But the achievement came at an unspeakable price. Tens of thousands died to build Buna factories. The technology that enabled Germany's war effort was produced through industrialized murder. Today, synthetic rubber is ubiquitous in tires and countless other products. The name Buna itself largely disappeared from commercial use after the war, replaced with terms like SBR, styrene butadiene rubber. But the chemical process invented in 1929 remains fundamentally unchanged. Modern synthetic rubber is based on the same copolymerization discovered nearly a century ago. Germany lost all rubber sources at the outbreak of World War II. Chemists invented Buna to sustain the Wehrmacht. The invention worked, and that success prolonged a war that killed tens of millions. That paradox defines the Buna story, a triumph of chemistry that enabled a catastrophe of history. Claude is AI and can make mistakes. Please double-check responses.